minus x raised to power 1 5c1 times by 3 to the power of
You
4.
can see, wait. You can tell me just what you will do for the second bit. Suppose we have to find the value of 2.9 raised to power 5 exactly. I'm not saying solve it exactly. Just tell me what you will do for the second bit. That's the only thing I want to know.
Um, well, since it's hence, I guess I could like maybe like equate it to like the power of 5 in the first one that I get.
No. See, basically you have expanded for 3 minus x raised to power 5. You will have so and so expansion, right?
Oh, wait, it said descending powers of x. I'll have to switch it.
No problem. See, that's okay, fine. You can do it. I know. You can expand, right? I am interested in the second bit. How you can use this result to write the exact value of 2.9 raised to power 5. That's the thing. First thing you can write it, I know, in ascending or descending, whatever. You can manipulate, you can adjust, you can uh, handle it. But what you will do for the expansion of 2.9 raised to power 5? Are you getting my audio?
Hmm? Yeah.
Yeah. So tell me what you will do to find the exact value of 2.9 raised to power 5
What would I do to find the exact value of 2.9 raised to power 5?
when the calculator is not allowed.
Um,
Okay, so let me discuss. You are taking too much time. See, so basically, this expansion or any binomial expansion is an identity, right? This is an identity. What is the meaning of identity? Identity means this is true for all values of x. You can put any value of x, right? So now think what I should put x here so that this becomes 2.9. So obviously you can think that if I put this 3 minus 0.1, see, if I substitute the x value as 0.1 and raised to power 5, so will it be equals to 2.9 raised to power 5?
yeah.
Obviously, see, so in all places in your expansion, just replace your x value as 0.1. You will get your answer. And the interesting part is whenever you have to do the power on 0.1, suppose 0.1 raised to power 1, 0.1 raised to power 2, 0.1 raised to power 3, like this. So for these things, you don't need any calculator. This is just zero point 0.1, this will be 0.01, this will be 0.001. Are you getting the point? So you can solve it exactly. You can find the value of 2.9 raised to power 5 exactly without using the calculator even. Any doubt?
Okay. I get this.
Okay. The last one. Wait. So many concepts. So you are familiar with the general term expansion TR plus 1, right? It must be clear.
Yeah.
Very nice. So this is the last question from the binomial. After this, I will switch to the other topic. Let us see this one.
Write down the quadratic expression in the form. Okay. Um, ax minus, okay, so 2 factors of minus 6, right? So 3x 6. Plus 6x minus x 2 3x. Hmm. Bracket x plus 2 minus 1 bracket x plus 2 3x minus 1 and x plus 2. Okay, hence or otherwise find the coefficient of that the expansion. Hmm. Okay. So here's the power of 5. Power of 5. And see. Find the coefficient of term x to the power 9.
Mm.
Um. Okay, I might have one idea.
Mhm.
This is take long.
Yeah, this will be very calculative one. You have to take all
X
the
to
things.
the power 9. There's a lot of combinations that can make that.
Hmm.
Um, so
Okay,
maybe
so
I
this is a
guess
higher level question. So, okay, if you want, we can skip this. Okay, tell me the next topic.
series, geometric, arithmetic series, sum to infinities, all of that. And like
Arithmetic and geometric series both, right?
yeah, both.
Mm-hmm. Okay. So, first of all, are you comfortable with all the formulas? It means sum to n terms like this.
Yeah, I get a formula sheet in my like thing anyway.
Mhm. Okay. So let me give you interesting question. Word problem title. Okay.
Oh yeah, wait. I got a question, right? Based off of something. Hold on.
Mhm.
I didn't understand how to do it, right? So
Mhm.
can you explain it to me?
Yeah. Yeah.
Okay, the thing goes 3, 7,
Wait. 3, 7.
3, 7, 13,
Mm-hmm.
and 24.
Mm-hmm.
I have to find the sum of the first 8 terms of this.
Okay. The sequence is going on. We have to find S8, right?
Yeah,
Okay. So, okay. First of all, please try to find which kind of this sequence is. So
I
first
tried. It's like
delta one. Let us find the first difference. The delta one, the first difference. This is the plus 4. How much this? Plus 6. This is how much? Plus 11.
yeah.
Correct. This is not constant. So please find delta 2 now. It means difference of difference. This is 2. This is 5. Still not constant. So for this, let us find the next one. Uh,
He said my teacher said it's like the combined of like a geometric and an arithmetic. They combined and like two sequences into one, and you have to like split them up and find the sum of them separately.
Only 4 terms are given or more?
Yeah, I've been only been given 4 terms, and he said that there's an arithmetic series in this, and a geometric one as well. I have to
They
like
have,
split the two of them up.
wait. They have told, your teacher has told you, or is there any written statement?
No, no, no. My teachers told me. Like I asked him to tell me like a tricky like question on like
Hmm.
the thing, right? And
Hmm.
he said that there's a arithmetic series and geometric series in this.
Arithmetic and geometric.
And you have to split it up into two series and find the sum of the series separately and like add it. Like I'll tell you what, like as per what I worked out, you have to write the arithmetic series is gonna be 2 comma 4,
Hmm. Wait, 2 comma
2
4.
4, this is
Hmm.
sorry, this is geometric, comma 8,
Hmm.
16,
Hmm.
and on the bottom below that, right,
Hmm.
1, 3, 5, and 7.
1.
3,
Hmm.
5, and 7. So like I did it in a way where if you add the things, you get the numbers. Like you get 3, you get 7, you get 13. And so do I now just find the sum of these two separately?
You have thought these series yourself, or your teacher has given this idea?
No, I thought of this myself. He just said
Very,
to like split up two series.
very good, very correct. This is working. So the first way is, see, this eighth term, the sum of eight term to find, it's not a very big term. So the first way will be, just find the eight terms. For example, four terms are given. You need to find just more four terms, right? More four terms, and then you will have the eight terms and you can solve it. This is the first method. The second method maybe is, the second method will be, first of all, can we write the nth term for this one? What should be the nth term for this expression? It will be, this is a geometric series, so it is
2
a
times
r raised
by
to power n minus 1. Yeah, so it should be
2,
2 times 2 raised to
2,
power n minus 1.
and
Correct. What is the nth term of this one? It should be a plus n minus 1 into d. So what should be the a?
1
A is
plus
1
n
plus
minus
n minus
1 and
1 into 2. So please simplify this. So it will be 1 plus 2n minus 2. So this will be 2n minus 1. Correct. So the overall term for my sequence is what I'm doing here. So I'm adding all the terms. So it is 2 times 2 raised to power n minus 1 plus 2n minus 1. Am I right? So it is what?
yeah.
You can simplify this. It has the power 1. So it is 2 raised to power n minus 1 plus 1 plus 2n minus 1. So it is 2 raised to power n plus 2n minus 1. Is it okay? Please see here.
Yeah.
You can verify. If you put n value 1, put n value 1, are you getting 3 on? So put n value 1. So 2 raised to power 1. 2 raised to power
2
1
plus
is 2.
minus 1. Yeah, yeah, you are.
2 plus 2, 4. Yeah. N value is 2. Is it working? 2 to the 4, 2 square 4, 4 plus 2, 6, sorry, 4 plus 4, 8 minus 1. Yes, this is working. So we have the sum for, we have the nth term for my sequence as well.
Yeah,
See.
also I had another thing on binomial, right? So suppose if you're given square root, right?
Hmm.
1 plus x,
1 plus
1
x.
minus x, like square
Hmm.
root, the whole thing, like 1 plus x divided by 1 minus x.
This
Right, so in
upon
this, right, I have to like find the like coefficient, right? So I just split the square roots, like put into multiplication.
coefficient of, okay. So yes, this is square root of 1 plus x upon square root of 1 minus
I
x.
use the yeah, I can use the, what do you call it? What's that formula again? A plus, no, 1 plus n x to the whole power.
Yeah. So in that case, if you have the fractional power, you will use the expanded of NCR form, like 1 plus
Yeah, then
nx.
I find
This
all the
is 1
solution.
plus nx plus n into n minus
n
1 by
minus 1
factorial
over 2
2x square
factorial.
like this. In this way, you can proceed.
Yeah.
I have a question
Okay.
based on this also. If you want, I can give you.
I'll do the series one first, and then we can do that.
Okay. So now we have this. So if we are going to find the Sn, right? So this is a way if you solve for this Tn, if you solve all, if you find the sigma of all your Tn, you will get the Sn. So basically, we have to find Sn for 2 raised to power n plus 2n minus 1, right? So this is
Yeah.
nothing but summation of 2 raised to power n plus summation of, we can write 2n minus summation of 1. Is it okay? See,
Okay.
ultimately, I'm giving you the general result. So in this way, suppose you are finding the general expression for Sn. Suppose. So it means I'm adding from n is equals to 1 to n is equals to n here, n is equals to 1 to n is equals to n here, n is equals to 1 to n is equals to n here. We are finding the n expression in terms of n. So this is what? 2 raised to power n is what? This is 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 plus dot 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 plus 2 raised to power n. This is the sum of GP. This is the GP, sum of GP.
Yeah.
This is the Sn. So it is what? A 1 minus r raised to power n upon 1 minus r. Or since my r is greater than 1, so I should use a r raised to power n minus 1 upon r minus 1. What is a? A is 2. What is r? 2 raised to power n. How many terms it has? If it is the first term, power is 1. If it is the second term, power is 2. If it is the nth term, it means 2 raised to power n minus 1 upon 2 minus 1. That is 1. So we are getting 2 times 2 raised to power n minus 1. So for this term, I should write 2 times 2 raised to power n minus 1 plus, what is this? Summation of sigma of 2n. So 2 becomes outside and this is the summation of n. So this
Wait,
is
why
2.
can't I just manually just find the sum of both of them and add like the value?
That I have already told you in the first method. This is very simple to add to find the first four terms, remaining four terms of each and every both the series and add them manually. This will be very easy. But I know you want to know the general way to solve it or to find the general expression for Sn. So that's why I'm going in this way. Otherwise, I have told you in the first attempt, in the first method, that find the first four, the remaining
Yeah,
four
okay. I
terms.
also have one question. You had taught me something in sigma, like suppose if it's sigma and on the bottom is like 15 and on the top is like 45, right? Would there be 31 terms because it's
Wait,
n
wait.
minus
You want to, okay,
1
wait,
plus
wait, wait. N is equals to 15 to 45.
45? Would there be 31 terms because it's
I
n
have
minus
already discussed.
45 minus 15 plus 1?
Yeah, we have already discussed these things, if you have remembered. Have you remembered? We have covered all these things, how many terms, how many numbers in between 15 to 45.
Okay.
So sigma 2n will be this. And sigma n, we have the formula sum of first n natural numbers. It is n into n plus 1 divided by 2, right? So this will be, and this 2 and 2 will be cancelled out, obviously. So it will be n into n plus 1 minus this will be n directly. So when we will simplify it further, so we will get 2 raised to power n plus 1 minus 2 plus n square plus n minus n. This n cancel out. So we are getting 2 raised to power n plus 1 plus n square minus. Put the n value 1. Put the n value 1. What we will do? We will get 2 raised to power 2, that is the 4, plus 1 square, that is the 1 minus 2. 5 minus 2, that is the, what was the first? Yeah, first term is 3, correct. If you put n is equals to 2, what I should get? 2 raised to power 2 plus 1, it was 3. 2 raised to power 3, 8, plus 2 square, that is a 4, minus 2. 12 minus 2, that is a 10. Yes, it's working. See here, If you add the first two term, are you getting 3 plus 7, 10? See,
Yeah.
if you want, we can check for n is equals to 3 also. So put n is equals to 3. So it should be, if you put n is equals to 3, 2 raised to power 3 plus 1, 4, 2 raised to power 4, 16 plus 3 squared, that is the 9 minus 2. So 25 minus 2, that is the 23. Let me check. Yeah, 10 plus 13, 23. So it's working now. So are you getting, we have discussed the direct way, the simple way, and we have discussed the general way also if we have to solve for this, how we can proceed. Any other doubt in this question?
No. We can move on to the ones that you gave.
This one, this square root binomial way,
No, no, no.
right?
You gave one about the geometric or some serious question, like the word
Okay,
problem. Yeah,
okay.
this one.
Oh, oh.
A 3D printer builds a set of 49 Eiffel Tower replicas in different sizes. Wait. Okay. The height of the largest tower. Okay. The height of the, are 95% as shown in the diagram. Find the height of the smallest tower in this set. So wait, can't I just do some like formula like 64 times by 0.95 to the power of like
Find it. You can use your calculator. Is
to the
calculator allowed
power
in your
of,
paper?
yeah,
Okay, so use your calculator. Note.
yeah, you get 52.1284 if I do that. Let me just make sure 64 times 0.95 times 0.95 times 0.95 times 0.95. Yeah,
You're getting
52.128.
how much?
52.1284.
Are you sure? Okay.
64
Mm-hmm.
times by 0.95 to the power of 4.
Why 4?
Because there's four other ones. The smallest one is gonna the the big one is H, then 0.95, another 0.95. I need
See,
four
wait, wait,
0.95
wait.
divided by
You
1.
have not go through your questions completely. A 3D
Oh, it builds
printer
a
built
set
a
of
set of
49.
49 Eiffel Towers, Ravi.
Oh, so then I'll put 49. Okay. 64 times 0.95 to the power of 49. 5.18.
Yeah, whatever. That is correct. Okay, find the next
Find
one.
the total height if all 49 towers were placed on top of one another.
Yeah, I think you can solve it, right?
Okay, so look, I can do n over 2 a plus l, right? Because I have 64 and I have the last one.
What you are saying?
I can do n over 2 a plus l, right?
N over 2? Why n over 2?
Oh, wait, then wait, what kind of a thing even is this? It's
Why
just
n over
geometric.
2? Tell me.
Oh, that's for arithmetic.
Is it arithmetic?
No. So wait, you have a times by r.
Mhm.
Wouldn't it is your r just 0.95?
Uh, yeah.
Oh, so n minus 1. Okay, so 64 times by 0.95. Wait. Wait, I don't know how am I supposed to like do the thing?
It's a very
Okay,
simple
wait, hold
thing.
on, hold on. Oh wait, I think I got it. Okay, so 64. Okay, 1 minus. So 0.95 to the power of 49. Okay, so 1 minus answer times by 64 divided by 1 minus 0.95. Okay, I'm getting 1176.3. That's what I'm getting. Wait, what's the answer?
Its answer is 1180.
I have wait. I got
Yeah,
1176.3.
correct. I think that's the approximation error. It's a direct question. 1176. Yeah, correct, correct. Now let us see the next one.
I also want to do some questions on like perpendicular lines and like that.
Okay, okay. Please solve this one. Let me give you
Arithmetic
some important
has
question. I'm just giving you. You can solve it after the class also.
first term 45, so A is 45, right? Common difference CD minus 3 over 2. Okay. Given that the k term, find the value of k. Okay. So A plus n minus 1 and minus 3 over 2. I'll just put 1.5 minus 1.5. Yeah. So 45 plus minus 1.5 n plus 1.5. Okay, minus 1.5 n plus 46.5. Hmm. Yeah, okay, is equal to 0. Okay, minus 46.5. Okay, wait. Minus 46.5 divided by minus 1.5. N is equal to 31. Okay.
You got the answer for the first one, 31. Let me check.
Pretty sure it's 31.
Correct, correct. So, okay, just
Let S
skip this. Wait, wait. You can solve it now, I think. So, please see this one. There are some good questions. I'm just putting in your notebook. You can solve it later on also,
has
but
3 roots by. Okay.
these are
Oh,
mix-up questions.
I have one question, right?
Mhm.
Like when I'm given a cubic, right? How do I just factorize it? If it just tells me to like factorize a cubic.
There is one common method. First, find the first root by hidden trial method, right? And then you will get the quadratic quotient, and then you have to do your factorization of the quadratic expression. For that, you have so many roots, so many methods, and in this way, you will get your complete factorization.
Okay.
Wait, wait, wait.
The cubic polynomial is this by expanding. Show that
Just log is also in our syllabus, right?
yeah, logarithms is there.
Okay, so let us do this question first. Wait, just hold.
But the only question I'm getting on logs is about change of base. Mainly that, the hard ones, because
I am including this log with your sequence. Will it work? Will it be useful? I don't know if it needs the change of base or not, but this is the mix-up question of your sequence and
the
log.
first two terms of an infinite geometric series in order are okay, find the common ratio. 2 log 3x divided by 3 log. Okay, so wait, okay, 2 log 3x, right? So that's the same as log 3x squared divided by log 3x cubed. Yeah, the common ratio is just x squared over x cubed. So equal to 1 over x. Show that the sum of the infinite sequence a, which is first term 3 log 3x. So wait, so log 3x cubed divided by 1 minus r minus 1 over x.
Why you are going in so much complicated way? Common ratio.
What?
And wait, this is asking you the common ratio. This is a geometric sequence in order, right? So it means this is the, suppose this is the first term. If this is your first term, then this should be your second term,
I did
correct?
the. Okay.
So what's the common ratio is? Second term upon first term. So you should write first 2 log 3x upon 3 log 3x. Can you solve it? Is it simplificable? Why not we can cancel out this? So its ratio is 2 over 3. What's the problem?
Oh, my. So log 3x 3 divided by third.
You getting? This is a simple question, but why not? I You are unnecessarily taking this as very serious, right? This is a simple question. See this one. Second one. Show that the sum to the infinite sequence is this one.
Yeah, I showed that. Okay.
You have done this?
Yeah, I did it.
Very nice. Oh, fast. Yeah. So S infinity is A upon 1 minus R.
1 minus r.
So A is
And then you
3
do log
log
3.
3x upon 1 minus 2 by 3. That is 1 by 3. So 3 upside. So yeah, this is a very simple one. Correct. The first three terms of an arithmetic sequence in order are this, and this. Find the common difference D. Give your answer as an integer. These are just for your
Common
fear
difference is gonna
fighting.
be log
Yeah.
3x over 3 minus log 3x.
Tell me the answer
I mean,
first, solve it,
minus
and
x over 3 divided by x, so it will be x over 3 times by. Wait. Hmm. Okay. X over 3x, you get 1. 1 upon 3, 1/3. Okay. Let S6 be the sum of the first. Show that S6, right? So n over 2, 6 over 2, 2a. So 2 times that. So log 3x squared plus n minus 1. So 5. Common difference is 1/3, right? So 6, 2, right? 5. Okay, so 3 log 3x squared plus 5 times 1/3 is 5/3. Yeah. Yeah, okay, I can do that.
What's the answer?
S6 is equal to one third the sum of the infinite geometric series. Okay, so wait. 6
You have
log
wait,
3x.
wait. You have solved the common difference?
Yeah, I'm on question 2
Okay,
of the,
okay,
I'm on the
okay,
last.
okay, 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 okay. Very nice.
Given that S6 is equal to one third of the sum of the infinite geometric series. So 6 log 3x minus 15, right? One third. So 2 log 3x minus 5 is equal to um 9 log 3x. So you can minus, right? So log, okay, so log 3x to the power 9 minus log 3x squared, yeah, so x9, okay, so x to the power 7, right? Log 3x to the power 7 is equal to minus 5. 3 to the power of minus 5, right? Find x, giving your answer in the form a to the power of p. Oh, 7. Oh, okay, minus 5 over 7. 7, yeah, minus 5 over 7. Okay, so x is equal to 3 to the power of minus 5 upon. Yeah, wait, hold on.
Mhm.
Yeah, wait. Whoa. Hold on, just 1 second. Yeah, okay, x is equal to 3 to the power of minus 5 over 7 for the second one.
Uh,
You have to
what-
equate the two things. The sum of infinite
X is equals to 3 raised to power 5. The last one, right? The last bit you are solving, right? It should be 3 raised to power 5. I'm saying for this answer. X is equals to 3 raised to, no, no. For this one, X is equals to 3 raised to power
for
5.
2.
You want for the second bit?
For question number 2, right there.
Yeah.
That's the answer.
Mm, yeah. So 3 raised to power 5.
I
I'm
got
getting
whole
3.
I'm getting log 3x to the power of 7 is equal to minus what?
Wait, let me show you.
Given that S6 is
Let me show
one
you. You are
third.
doing some mistake here. Wait, let me show you.
I think I'm right. I don't see what I'm.
No problem. I'm here for your discussion. So see where you are doing mistake. Hello.
It said that given that S6 is equal to one third of the sum of the infinite. Oh,
Obviously it is given. What are you doing? See, it has written that S6
I
is
did.
equals
I
to
thought. I thought one third of S6 was the sum of the infinite
what you are
geometric
doing.
series.
What you are doing account. S6
Given
is. It means S6 is your subject now.
is equal to one third. Okay, then yeah. Let me see. Yeah. Okay, I think I can do this now.
So tell me the next topic quickly.
Like lines, perpendicular lines, like equations of lines, that kind of stuff.
After that, after perpendicular lines.
After that, alpha beta.
Alpha beta, we have discussed currently, right?
Yeah, so we don't have to do that. We also have, wait, what? You have factor theorem and polynomial division.
Okay. Wait.
Yeah, you have factor theorem, polynomial division, the line things.
Let's do the factor theorem and remainder theorem questions. Factor theorem and remainder theorem. I think I have given you a assignment based on factor theorem and remainder theorem. Have you remember?
I think you have binomial,
Let's see this one.
quadratic functions. No.
I, okay, no problem. Let's see this one.
Coordinate geometry. It doesn't look like it.
Let's solve. See this when px equals to this is divided by this, the remainder is minus 5. Given that c and r belongs to your real number set, find the smallest possible value for c.
So you have x squared minus 2x minus c is divided by x minus r. So x is equal to r. Yeah. The remainder is 5. Given that c comma r. Oh, okay. So x squared minus 2x minus c. When divided. And divided by minus most possible value of c. Hmm.
Okay, should I discuss question number 10?
Just 1 second.
Mhm.
Yeah, you can discuss it.
Okay. So see, so we have p of x is equals to this. We have a polynomial, and it is saying that when this polynomial is divided by this another polynomial, so let me represent this in pictorial form. So this is x square minus 2 twice of x minus c. When this is going to be divided by x minus r, the remainder is minus 5, right? We don't have any information about our
So
quotient.
could I say minus 5 times the remainder, minus 5 times x minus r is the quotient?
And you're saying minus 5 times this x minus r is your quotient.
I think so, right?
By which rule? Can you justify this rule anywhere? Not, let us take some simple example. Suppose I'm dividing from 17 to 100, right? So 5 times,
Yeah.
correct? 50. So do you think that how you are correlating this? Is it working here?
No.
So how you thought, see, if you're not getting the correct way, at least avoid the incorrect way. Don't block your way. You are by adapting by using your incorrect way. You know this that this is not correct. I know that you are aware of this that this is not any rule, but you are using this rule, so you are blocking the way for the correct solution. Are you getting my point? If you proceed in this manner, you are blocking yourself. Have you seen any time that this times and this times equal to question anywhere, anytime someone has given you, you have visualized it anywhere? Tell me.
No.
Have you seen it anywhere? No. But you are forcefully applying this. Why? It means you are blocking yourself to get the correct answer. Think, stop, but don't adopt the wrong way. You know this. Okay. So this is not possible. Okay. So we have to find the C. We have to find the smallest and possible value of C. Now you have to be smart. This is not saying find the smallest value of C. This is saying find the smallest possible value of C. These are some hint. The biggest hint is this. See, right now we have two unknowns in my question. That is the C and this R. But there is only one information given that the remainder is minus 5. One information is given and unknowns are 2. It means this is not the case of simple situation. This is a smart situation. This is a smart case situation. Am I right? You know all these things. We have two unknowns, but one information is given. Are you getting my point?
Yeah.
So, what's the remainder theorem says? What's the remainder theorem says? The remainder theorem says that if I make this divisor equals to 0, so x minus r is equals to 0, so it means x
X is
equals to r. So if I substitute this x equals to r in my dividend, I should get the remainder, right? So it
yeah.
means if I do this, so I will get r square minus 2r minus c should be equals
It's
to
the
minus
same.
5.
Yeah, that's what I did as well.
Okay, okay. Now we have to work for c. C is my targets. So make C as a
So
subject
you know what
first.
I did? I moved C to the other side. So I
Yeah,
wait.
so R
Wait.
square minus 2R plus 5, right? Spin it out.
Okay.
Can you see this is a quadratic equation? This is a quadratic, not equation, this is a quadratic expression. R square minus 2R plus 5. Am I right?
Yeah.
Can you tell me the range? Or can you tell me, or can you write this in completing the square form? Can you write in completing the square form? So yes, we can write it. So it should be R minus 1 whole square, right? And then plus 1 square and then plus 5 once again. Are you aware of these things? How to write in completing the square method? So it will be R
X.
minus 1 whole square.
Wait. It's gonna be X plus B over
Yeah,
2
sorry.
whole squared
Wait. It should be
minus
minus.
B over 2 whole squared plus C. Right?
What are you saying?
X plus B over 2 whole squared
Yeah,
Minus b over
correct,
2
correct,
whole squared plus c.
correct, correct. So what we are getting? We are getting r minus 1 whole square plus 4, isn't it? See, this is the expression for C. Now r is your any number belonging to real number, right? Correct. So r is from your real number set. So r minus 1 will also be a real number, correct? And you have the square. It means it is 100% guaranteed that this first term will always be greater than equals to 0. Am I right?
Yeah.
So what should be the minimum value? If we are looking for the minimum, so this first term will be minimum 0 and this plus 4, so 4. So the minimum, the smallest possible value for C should be 4. Tell me any
Okay.
if you have.
Okay, I get it now.
Similarly, there are so many questions here. If Px equals to
Also,
this,
I have one last doubt that I want to ask you, right?
hmm hmm
Suppose I have maybe 3 plus 2x,
hmm
right? Raised to the power of like a third, okay?
three, okay,
A third, one third, one
one
third.
third, okay, you want to say one third, okay.
Yeah, okay. In this, right? When I factor out the 3, right? What will I have to do to find the modulus? Will I do the modulus of 2/3 x, or will I do the modulus of 2x to see if it's like a.
I'm not getting your question. What are you saying? This is the expression. Suppose this is the Px, then
Yeah, 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 yeah. Like you know how you do the modulus of x has to be less than 1, right?
modulus x has to be less than 1.
Yeah, there's like this rule, right? When do you
Okay, in
use
the
this
binomial,
modulus thing?
in the binomial.
Yeah, in the binomial
Okay, so
itself.
you should tell me. Okay, then okay. So see, this binomial will it should have
Do I
one
use
plus.
modulus of 2 over 3x or
I'm
2x?
explaining, sir. You just listen. You should have 1 plus minus x raised to power any power like n. So first of all, you have to make sure that your this first term should be 1. So what I should write? You will take 3 as a common, then you will get 1 plus 2 over 3 raised to power x, and then complete power 1 by 3. So you will get 3 raised to power 1 by 3, and then it will be 1 plus 2 over 3 raised to power x, and then whole power 1 by 3. Now you have the condition on this one. This 2 by 3 x modulus should be less than 10. Any doubt?
Oh, okay. Okay, so you use it like that. Why don't I just do modulus of 2x is less than 1? What's the
Sorry?
difference? Why don't I just write modulus of 2x is less than 1?
No. Very good question. Can you tell me why? Okay. Can you tell me?
Hello? Hello? Hello, are you there?
Wait, wait, wait. Are you getting my audio?
Yeah.
Okay, wait. Wait, wait. Huh? Hello, Manch, are you there? Hello, 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 hello.
Yeah, hello?
Okay. So now, first of all, you tell me 1 plus x raised to power n, right?
Yeah.
Why you want this x to be less than 1? Tell me. Why?
Because like, isn't it to do with like something that it converges or something?
Yeah. So basically, when you will expand this, in the first term, you will have x raised to power 0. In the next term, you will have x raised to power 1. After that, you will have x raised to power 2, and so on, right? And in mathematics, we have a property that if your base is between 0 to 1, if your base is between 0 to 1, and if you are rising your power, the value gets decreased. Do you know this? Do you know this?
Yeah.
So if you make sure that this second term is such a number which is lying between 0 to 1, if you make sure that this second term is such a number which is between 0 to 1, and in your expansion, what you are doing, your power of x is going to be increased gradually. So what we will do basically, this is used for linear approximation. This will be used for linear approximation. What is a linear approximation? It means if you have such a condition that your x is going to be between 0 to 1 or less than 1. So what will happen basically, higher terms will get neglected. Why and how? That's the concept I have already discussed here. That if your x is between 0 to 1, and if you're rising your power gradually x3, then x raised to power 4, and so on. So these will be not a very significant thing because your x is already less than 1 and you're rising your power. So these will be neglected. So you will have only first two or three terms you can take. It will be a good approximation for your final value. So this is related to you not only the expansion, this is related to the linear approximation. For the expansion, you can expand it, no problem. But if you are approximating it, so you can do such approximation, such cancellation, if and only if your second term should be less than 1. Are you getting my point? Now tell me, if you're using this twice of x, you are asking why can't we apply this condition on 2x? So are you guaranteed, are you taking the guarantee that this 2x will be less than 1? How we will take
No.
this guarantee? And the second one, this first one is also this 3. So in this sense, and why we are making this 1? If you make this first term as 1, if you're making this first term as 1, so the expansion is very, very simple. Why? The first term is 1, so any power to 1 will be 1. And the second thing is, see, if you are expanding this 3 and then 2x, so obviously, if your x is less than 1 here also, so twice of x will be also less than 1. But please see, if you apply your condition on twice of x, it's okay. If your x is less than 1 or less than something, we can solve with this condition. If 2x I want less than 1, it means x should be less than 1 by 2. No problem. But what's the problem is, in your each and every term, this 3 raised to power something will play a significant role also. Are you getting my point? In the first term, it will be 3 raised to power 3 raised to power. What first term? It will be 3 raised to power the complete power, right? And after that, it will decreasing, right? Are you getting my point? The
Yeah.
first term will have the maximum power, and then gradually it will going to decrease. So it means the terms will be neglected or not, it will not be decided by just 2x. You have to see this 3 also. What is the power of 3? Please see. If you are not making this first term as 1, then to neglect or not neglect, this will be decided not only with twice of x, you have to see this 3 also because there is some power on 3 also. Are you getting my point? But if you make this as 1, so the whole decision will be based on this 2 upon 3x only. So due to this reason, we must make it as 1 plus something. Is it okay? Any doubt?
No.
Okay. Any other doubt? Rest of all, see, we have already done, but make sure the fundamentals should be clear. If you have any doubt, you can message me. I can help you.
Yeah.
Okay?
Okay. Thank you.
Okay, Akans. Thank you. Take care. All the best.
Bye. Thank you.